To detect lines in an image, we first need to find edge pixels. So let's load an image, convert it to grayscale, and find edge pixels using the canny operator. Let's see what these look like. Here's the original image. As you can see, it has some lines in it, the grayscale version, and edge pixels. Now we'll apply the Hough transform method to find lines. For this, we'll use the Hough function in MATLAB. Find out more about this function in the MATLAB documentation. The equivalent function in Octave is HoughTF. The first return value is the accumulator array. The second is a vector of theta values, or angles. And third is a vector of radius values, or rho. Let's see what this looks like. We pass in the theta and rho values to properly label each axis. Rho, or distance from origin, is along the y-axis, and the angle theta is on the x-axis, ranging from -90 to +90. Okay, so let's find the peaks in this accumulator array. We pass in 100 as the maximum number of peaks we are interested in. Note that a similar function called immaximas needs to be used in Octave. Let's plot these peaks on the Hough accumulator array. Note that we need to use the theta and rho values to plot the peaks correctly. The peaks are marked by small red boxes. The size of the peaks matrix is 13 by 2. 13 peaks were found. Each row contains the location of a peak. The first column has rho values or y values, and the second one has x values. Using these peaks, we can find line segments using the Hough lines function in MATLAB. It looks like 28 line segments were found. Each element in line segs is a structure with the two endpoints, the theta and the rho values. Let's plot these line segments. As you can see, most of the longer line segments have been detected, but a lot of spurious line segments also show up. Okay, so how can we get better results? Let's take a look at the edge pixels again. We notice that there are breaks along the longer lines in some areas. There is also this dense grouping of curves that could throw the Hough detector off. To find a set of cleaner or more meaningful lines, we can do multiple things. For instance, we could increase the threshold parameter for Hough peaks. To understand what these parameters mean, let's look at the documentation for this function. So threshold is the minimum value in the accumulator array, that is the minimum number of pixels that support a line required for that line to be counted as a valid candidate. Any possible lines with less pixels will not be considered. Here we set it to be 0.6 times the maximum value in the accumulator array, the default being 0.5 times max. Neighborhood size defines the region over which local maxima will be computed. Note that this is not a region in the image. We are computing local maxima in the accumulator array. So the size of the neighborhood is defined in rho and theta dimensions. A neighborhood size of 5 degrees along the theta dimension means that a strong line will suppress other lines that are similar but slightly off in direction. Recall that we found 13 peaks in our last attempt. This time we have only 7 peaks. Let's see where these peaks are. Looks like we might have cleaner results after all. Let's compare this with the previous accumulator peaks. We see that a lot of the previously found peaks in this dense region are now gone. The new peaks are clustered around 3 major locations. Okay, what more can we do? We could play with the parameters of Hough lines. How about we increase the fill gap parameter to 50? This is the maximum number of pixels allowed between two segments for them to be counted as one if they lie along the same line. To focus on longer lines, let's increase the minimum length to be 100 pixels. For a better understanding of these parameters, take a look at the documentation for Hough lines. Okay, let's see what the new segments look like. Compared with the previous results, we see that the false positives have been mostly removed. Some of the previously broken segments have also been joined. Obviously, you can do a better job by playing with the parameters, especially here. So feel free to play with the Hough transform functions.